Remediation of PCB-impacted soil at a former manufacturing site presented a complex characterization and excavation challenge. The site included 3 discharge lagoons with capacities ranging from 350,000 to 1.5 million gallons, a subsurface aeration basin, and 2 large buried waste disposal pits. A large body of data was collected from over 300 borings consisting of analytical samples, visual observations of oil, and lithologic logs. EVS was selected to serve as the spatial decision support platform. Sample results were continuously loaded into the 3D visual database as field efforts progressed, enabling real-time delineation of plume geometry and minimizing the number of additional borings required. PCB concentrations were kriged from analytical data and visualized against risk-based thresholds, while lithologic controls on contaminant migration were analyzed through cross-sectional slicing. The union of PCB plumes exceeding 10 ppm and visual oil impact plumes defined the excavation envelope. PCB plumes were also evaluated at a 50 ppm threshold to quantify and evaluate materials that may have required different disposal criteria or treatment technologies. We have added X and Y plane sliding axes. The distribution of the PCB and visual impact plumes are often discontinuous, and these slices enable measurements of depths of impacts and thicknesses of individual plumes. EVS used the boring logs to create lithologic layers from the 6 materials encountered while drilling. We begin by showing the entire block, then progress by removing layers downward from the top. Note EVS's ability to cut the layers surgically by the highly varying surface down the hill and into the lagoon. Also, the trapezoidal aeration basin is used to cut through the geologic layers. Such extremely challenging surfaces can be precisely handled by EVS. Now we showcase EVS's ability to show individual layers, one layer at a time. Now we put the PCB plumes and visual impact plumes together with the geological slices. These slices can be moved to any X or Y plane desired to allow measurements of elevations or depths of the very complex disconnected plumes of the PCB and visual impacts. Control of the plume distributions by the various lithologic layers can be studied in detail. The following sequence shows the ideal bottom excavation surface, which encompasses the union of PCB plumes and visual impact plumes. This portion shows the output of the surface as a 3D PDF. This capability of EVS provides embedding of interactive pages directly into PDF documents. Model outputs were exported to TerraModel earthwork design software for detailed excavation engineering. The resulting design surfaces define clean overburden, reusable benching soils, and PCB-impacted material as distinct stratigraphic zones across the full 50-foot excavation depth, broken into 1-foot slice intervals for contractor planning. Those surfaces were then loaded directly into GPS-equipped computer-guided excavators and bulldozers, providing operators with real-time positional data relative to predefined excavation boundaries. This eliminated field-level decision-making, reduced work interruptions, and enabled optimal segregation of two distinct waste streams throughout the excavation sequence. Predicted excavation quantities included approximately 14,000 cubic yards of PCB-impacted soil requiring off-site disposal, 37,000 cubic yards of potentially impacted material, and 34,000 cubic yards of clean overburden and benching soils reused in site restoration. By linking EVS's visualization and analysis capabilities directly to field implementation, the project team achieved precise, defensible, and cost-effective remediation of a technically complex site.